I'm going to be talking about linear approximations and Newton's method. A linear approximation is a way of approximating unknown values of a function close to a known value. For example, say we have a function that looks like this. Here's the y-axis and x-axis, and a function like that. Now suppose that we know the value at this point exactly. Let's call this x0, but we don't know the value at point x1 around here. So what we can do in this situation is find a linear equation which closely resembles this function close to the point x0. Then this can help us find the value of the function at a point x1 close to the actual value. So the best way that we can approximate this function with a line around x0 is with the tangent line, which just looks something like this. Now we know that the slope of this tangent line is equal to the derivative of this function, let's call it f, at the point x0. So we can write out the line's equation using point slope form. So the point we have is x0 comma f of x0, and then so the equation of our line will be y minus f of x0 is equal to f prime of x0 times x minus x0. Or we can write this as y equals f of x0 plus f prime of x0 times x minus x0. Now to approximate the value of this function at x1, we want to figure out what the value of this line is at x equals x1. So we can write that as f of x0 plus f prime of x0 times x1 minus x0. This gives us a reasonable guess as to what the function's value is at x1, while only using information about f at x0. Another thing that we want to be able to approximate is the zeros of a function. Suppose that we have a function that looks like this. And let's say we know how to evaluate this function at any point, but we don't know where this function's zero is at, which is right here. So we want to know what x value corresponds to this point. A very good way of approximating this x value is by using Newton's method. The first step of Newton's method is to guess some point that you think is close to the zero and use that as an initial approximation. So let's say that we start at this point here. So the idea behind Newton's method is to use a linear approximation of the function around this point and find the zero of that, which is right about here, and then trace that up to the function to get a new approximation. So what I've done here is approximate the function with a tangent line and find the zero of that instead of the zero of the actual function. Now this isn't going to give us the zero exactly, and it might not even be that close, but it'll definitely be closer than what we had before, at least if the function is nice enough. So from here we can just repeat the process and find another tangent line, and then find the point where that's zero at, and trace it up to the function, and continue doing this until we get arbitrarily close to the actual zero. So now that I've given you an idea of what this method is about, let's do the math behind it. So let's assume that the starting point was x0. Then the equation of our tangent line is going to be y is equal to f of x0 plus f prime of x0 times x minus x0, as we saw before. Now since our goal is to find the zero of this function, we set this equal to 0. We have 0 equals f of x0 plus f prime of x0 times x minus x0, and we solve for x. I'll skip over the details here, it's just a linear equation, but we end up with x is equal to x0 minus f of x0 divided by f prime of x0. So this will give us the value of our next approximation, which is right here. We can call it x1. Then in general, we'll have xn plus 1, the n plus first approximation, is equal to xn minus f of xn divided by f prime of xn. By repeating this process over and over again, we can get very good approximations of the actual zero very quickly.